Hello, everyone. Welcome to the HackFS 2024 CoopHive workshop, Tokenization of Latent Computing Power. Joining us today is Levi Rybalov, who will be taking us through this session. And with that, I'll pass it over to Levi to get the session started.
Hey everyone. Hi. My name is Levi. I'm the founder of CoopHive. So I'm going to give a bit of background about what CoopHive is, how it started, what we're building, and how you can win some prizes. CoopHive was originally built as an incentive mechanism on top of the Bacalhau distributed computing platform built at Protocol Labs. Bacalhau was and is, it still exists, of course, it's doing very well. It's a platform basically centered around compute over data. So you bring the data, compute to the data rather than the data to the compute. So if you have like a 1 terabyte data set over somewhere, rather than trying to pull it to some central server and computing over it, you just send the computation you want over to where it's located. And so you could do that on any device, anywhere from an IoT device all the way up to a GPU server and everything in between. And this was developed at Protocol Labs in particular to help basically provide compute over Filecoin data, because providing compute over Filecoin data dramatically enhances its value. And we're going to get to that later. So in May of last year, actually around the 1-year anniversary, Protocol Labs initiated something that they internally called Project Bravo, which was basically intended to build an incentivization layer on top of the Bacalhau distributed computing platform. Because at the time, there were no payments, there were no anti-cheating mechanisms, and so on. My job as a researcher was basically to go and figure out how are we going to price jobs, how are we going to prevent nodes from cheating, and so on and so forth. Internally, this was called Project Bravo at Protocol Labs. Externally, it was called LilyPad. LilyPad continues to exist. They're doing very well. They're actually in this hackathon as well. Both CoopHive and LilyPad both grew out of this underlying project in order to provide this incentivization layer on top of this distributed computing platform. So how does CoopHive work? CoopHive is a two-sided marketplace for compute. You have clients here and compute nodes here. The clients need compute. The compute nodes have compute. And what they do is they send their job and resource offers to a node in the middle called the solver. The solver acts as a market maker. It runs an algorithm that matches the client job offers with the compute node resource offers. It proposes the match to the two sides. If the two sides agree, they make a deal, and that deal is posted on chain. In particular, on chain is posted some metadata and also an IPFS CID that contains all of the data that isn't required to be on chain, right? So we offload most of the actual data onto IPFS, and we just end up with a pointer, an IPFS CID, which acts as a pointer to that data, right? With a bit of additional metadata that you need on chain. Then the compute node computes the result. It takes the result, it puts it onto IPFS, and it also posts the CID on chain along with IPFS CID on chain along with relevant metadata. So again, we end up with just a bit of metadata and a pointer to off-chain data, which can be quite large. And then there's an optional mediation process that is arbitrary. In fact, you can define it however you like. And that is if the client and, for more general long-term reasons, the compute node or really any entity wants to challenge the results of a computation, they can do that, and the results of the computation, the results of the mediation are again put into onto IPFS. The CID is put on chain, and again, just a bit of metadata is associated on chain. And so basically, what we end up with is a sequence of IPFS CIDs. Which is an extremely lightweight way to represent a very complicated series of computations that could be arbitrarily expensive, that can denote running any Docker or Wasm container on an IoT device or a laptop or a mobile device or GPU server or whatever. So it's basically just a very, very lightweight data structure. It's just IPFS CID after IPFS CID after IPFS CID. And that's basically the core of it. And so that's basically at its core how Co-op Hive works and what it provides. And so what it allows you to do as a developer is basically call any job that you'd like that can be run by a compute node on the network with basically just one command line interface, like a line of code, basically. It just says, for us, it's Hive run this, GitHub repo, and boom, you can basically run any computation anywhere you like. It's very simple and flexible. And so, I wanted to also go over about, what are the actual bounties about. So, the bounties basically are centered around the tokenization of latent computing power. And so for this, I'm going to give a bit of history. Back in the late 90s, there was a an attempt there was a project called SETI at Home, the Search for Extraterrestrial Intelligence at Home. So they were searching for aliens. But they needed a lot of computing power to do that, and they didn't have it. So what did they do instead? They went to volunteers all around the world, and they said, hey, can you do this little bit of computation for me? And they sent that computation to that node. The node did the computation. It took the result and it sent it back to the central servers, the SETI at home server. And many hundreds of thousands, maybe even millions of nodes around the world participated in this. I don't remember the exact number, certainly in the hundreds of thousands. Very, very, very popular. And out of that grew the Berkeley Open Infrastructure for Network Computing, also known as BOINC, which grew out of SETI at home, but also generalized it so that scientists could run any kind of computations, not just searching for aliens. There was another very famous and related project called Folding at Home, which is centered around protein folding and other kind of protein dynamics and so on, and which is also very popular and still continues to this day. And so basically, if you look at what is really happening from kind of a higher level economic perspective here, the scientists were taking a look at all of this latent computing power all around the world on laptops, well, actually at the time mostly on desktops, but now on really any device anywhere, and saying, man, there's a lot of wasted potential here, right? I mean, there was a lot of like energy that went into creating this computer, right? We had to dig up all these metals, we had to refine them, they had to go through all these like really expensive, complicated fabrication processes, and it had to be put on the market, shipped, put on the market, sold, etc. There was so much energy going into these, but they spend so much time sitting around doing nothing, right? When you're asleep, at the very least, right? Usually your laptop, your desktop, they're not really doing much, or your mobile phone even, they're not really doing much. And so what the scientists were really saying was, can we make better use out of this latent computing power than just having it sit idle? And what they did was they said, yes, I mean, we can totally do that. Let's just send out computations that we think are valuable that people would be willing to volunteer for. And that, again, was searching for aliens. I know a few years ago, they were helping find the structure of the spike protein, the COVID spike protein, mapping the Milky Way, making a three-dimensional map of the Milky Way. The CERN, the Large Hadron Collider at CERN uses BOINC for doing analyzing particle accelerator data and so on. So this is like absolutely massive, robust value that you can extract out of this latent processing power that's just lying all around the world, right? Now. What is the difference? Now, what were these projects lacking? That's a really interesting question, right? So these projects were lacking, they were basically centered around the traditional client-server model, right? They were basically, I am the, SETI at home server, whatever it is. I'm going to send out all these computations to all these nodes all around the world. And then I'm going to get the results back. I'm going to aggregate them locally. I'm going to keep it all in the local database. I'm going to, basically keep everything, close tight. What's the problem with this? There's a few. I mean, and this has nothing to do with any particular project at all. But we are now in the middle of a really big crisis in science called the replication crisis, right? There are all these scientific studies, even in the hard sciences, that cannot be replicated, where the processes were not documented well enough, where the computations were just not really documented well enough, or where even the code was not open source, so people can't reproduce the computations, right? We just have this like massive problem around like the reproducibility of science, and that's a really big problem, right? Because if you're trying to do science and you're basing it on other science that you're assuming was correct, but it wasn't correct and it's not reproducible, well, then what are you building on top of, right? You're building on top of a flawed foundation, right? And that those errors are going to propagate. And so it's a really big issue, if all of the data is just brought locally to the central server and all stored there is locally stored there, right? And so what can Web3, what can blockchains do to solve this problem? Well, we have a really good solution for decentralized file storage now, right? IPFS, interplanetary file system. I'm sure everyone here who's hacking at, the HackFS probably knows what IPFS is. It's a kind of decentralized peer-to-peer file sharing platform, right? You can take any data and just content address it, basically TLDR hash it, right? Take the hash of it and identify it by its hash. And now you can just spread it around the world, and you can locate it by its hash. You can locate it by what it is, not where it is, right? Which really helps enable data persistence and so on. We have this amazing tool called IPFS, right? Where we can actually now store that data, right? So whereas before, all of that data was being brought locally to that central server and stored locally, now we can actually take that data and spread it around everywhere to anyone who wants to have it and be able to reproduce the results, right? And to be clear again, we're talking about totally public data here, where nobody minds if it's out in the open. Things like scientific data, or environmental restoration data, or that data from Large Hadron Collider and so on, right? We're ignoring privacy concerns for the moment, although of course those are very relevant to what we're working on as well. So basically, we have this amazing file sharing program. We can just take the results of computations and store it on this decentralized network. That's awesome. Now who's going to pay for it? Well, it can be a bit expensive to store, terabytes or petabytes of data from scientific computations, right? And so this is where Filecoin's economics come in and are really interesting, because Filecoin has its crypto economic model is centered around driving the price of public goods storage down to zero, basically, right? And they use something called the Fill Plus program for this. It's basically designed to make it so that valuable data sets that are valuable to humanity, things like the Internet Archive, for example, to take that data and to make sure that it can stay around long term, right? And so one of the main foci of the Filecoin crypto economic system is to help store, in particular, data like the scientific data. And so basically, where does Co-op Hive come in? Well, remember what I was saying earlier, that Co-op Hive is really just, and by the way, of course, for those of you who don't know, Filecoin has proofs of storage, cryptographic proofs of storage that are proofs over IPFS CIDs, right? So you can prove that you're storing data on IPFS with Filecoin, right? And so where is all this going? Well, remember what I was saying earlier about how Co-op Hive is structured. At the end of the day, it's just a sequence of hashes, right? It's just a sequence of pointers, which are IPFS CIDs, that are pointing to off-chain data, right? Well, isn't that convenient, right? Because if you want to do some kind of massive scientific project that can bring enormous value to the world, and you want it to be stored in a decentralized manner so that anybody can reproduce it, so that anybody can take the input, compute it themselves, and make sure they got the same output. Well, look at this amazing, this file sharing system with this cryptoeconomic model built on top of it, with this compute marketplace built on top, which just so happens to record the results of the computations in the exact same format that is necessary in order to distribute it all around the world to anybody who wants to store it. And so this was one of the main building. But there are other reasons for why we architected it this way. But this was one of the main value propositions of Co-op Hive and of what we were building at Protocol Labs. It was basically to have a very lightweight sequence, very lightweight data structure that can facilitate computational reproducibility in scientific projects at large, right? And so if you go to our prizes for the HackFS prizes, you'll basically see, in fact, I'll just, I have a tiny bit of extra time, so I can just probably share my screen and show you. So HackFS. So 1 second, here we go. Okay, so that's the Filecoin one. Sorry, there we go. Okay, I'm gonna share my screen now. Okay, there we go. So basically we have 3 categories of prizes. So the first is the best use of public data sets in IPFS or Filecoin, right? And so basically the task here is very simple. Think about data that is stored on Filecoin or IPFS. Take that data and make it more valuable by computing over it. Whatever it is, think about, okay, this data is interesting. Can I do something interesting with it and make it even more valuable? From a business perspective, from a social good perspective, from a knowledge creation perspective, from really any perspective, can I take this data and just do something really cool and useful with it, right? So rather than having it lie dormant and idle, just lying around, can I do something valuable with it? The second category of prizes are basically, the best use of Co-op Hive for AI applications, right? So if you go on our GitHub, and I'll show that in a second, we can run basically any arbitrary Docker container, right? So that basically means we can run any AI workload, practically speaking. As long as you can Dockerize it, as long as you can containerize it, you can run it on our platform. And if you're having trouble with that, please come to us. We will absolutely help you. And so the second category of prizes are basically just the best use of an AI module on our network, right? And of course, this can of course tie in with the best use of public data sets as well, right? So the third category is basically what I was talking about. Here's a long rant I gave about like the kind of philosophy behind what we're doing. Basically, it's the best use of latent computing power. Can you think of this kind of scientific project, or really any project? It doesn't have to be scientific. It could be about environmental restoration. It could be analyzing data from satellites to reward carbon credits or whatever. You can be trying to log data from like many mobile devices or whatever it is. And it could be weather data, whatever it might be. Can you think of a way to look at all of these nodes that have so much extra computing power and just ask the question, is there anything that I can do with these nodes where nobody might be willing to pay for the compute now, but that somebody might be willing to pay for the compute later, right? There's something that it says, you know what, there's a possibility, right, that this can become valuable at some point. And so for those of you who are wondering, like, okay, so like kind of like from a business perspective, what's the monetization strategy here? Basically, if you have some kind of scientific project, and let's go back to, you can think about SETI at home. SETI at home gave out points. When people did their computations, they gave out, like, it was like a leaderboard, like Web2 points, like a scoreboard, right? Brownie points. Same thing with Folding at Home, same thing with all the other Boeing projects. They always give out these kind of points for what people did. Well, now imagine if those points were tokens, and those tokens were on a market. And you could somehow capture the value of those projects, those scientific projects that you're doing, right? So, you can either imagine, depending on how the project was structured from the beginning, the computation is being eligible for retroactive public goods funding, which is becoming increasingly popular in Web3. I think the Optimism had the first started at first. Filecoin just had their own version. I think it will become more popular. Um, and so if you structure the project that way, you can say, listen, we're going to do all of these computing projects. We're going to have a token for it. If it turns out that this is successful and valuable, well, we can reward it retroactively. Likewise, if from a different perspective, if you want to monetize it in a more traditional manner, you can try to make the tokens correspond to fractional ownership over intellectual property, right? And in that case, then the tokens are just kind of like your fractional contribution to this overall scientific project. And then you can monetize it that way, right? And so basically the price of the token when it's on the market would almost act in a way as a prediction market for the value of the project, for the value of the scientific computation. And so that's kind of like the main kind of focus, the main idea behind this particular bounty. It's, can you think of something that nobody might be willing to pay for now, but that somebody might be willing to pay for later? That's really the crux of it. And so I'm going to go briefly over just our GitHub super quick, just so you know how to run jobs and so on. And then maybe leave a few minutes for questions if there are any. So basically, here is the GitHub. We have a lot of other like repos that some of which are private and hopefully we'll be showing shortly because we're doing some really cool stuff. But basically, you go here, you go to your MetaMask, you add a network manually. And if you need instructions, you can go to our docs. We have an explanation of how to do that there. Then you go to our faucet. You get some faucet, some Hive, sorry, and it'll give you both ETH to pay for gas and Hive for jobs. Then you install the CLI. Literally, it's just copy this, run it, copy this, run it. That will basically download the correct version for the architecture that you need. Then you need to run a job, and so you basically go to the Web3 wallet that MetaMask or whatever you were using. You export your private key. And then here's two examples of a CPU job and a GPU job. So this is CPU job. This is basically our hello world. And this is a stable diffusion job that basically requires a GPU, of course. And naturally, you can run any GPU computation that you'd like as long as you can Dockerize it. And so this is basically how you can offer your node to the network. We have more modules than this. If you want, we'll release some of those a bit more. We kind of just have those kind of in private for a while. And then and then if you need to write your own module, basically you can basically create your own GitHub repo. A module is just a GitHub repo. So this is our cowsay module, for example. Basically, this is what it looks like. You kind of just need to add this like module.coop hive directory, and then into whatever you're running it. In fact, I think we have something. One second, I'm gonna just open up a new window here, just to make sure. Just to give you a sense of another thing that you can run. No, that's the one. I just want to show you real quick. Where is it? Here we go. Yes, here, perfect. So this is another really good example of something that you can run on our network. It is, there we go. So this is a module that converts PDFs to Markdown, right? And we're using this to create a decentralized vector database, actually. And so basically, all we did was fork another repo. So GitHub, it should be Vic. Yep. So he actually just refactored this amazing code. So basically, all we basically did at the end of the day was fork this repo, Dockerized it, and added a module.coop hive. That's basically it. That's all you really need to do in order to run your own any arbitrary workload that you want to run on our network. And so with that, I will finish it up and open it up to any questions.
Awesome. Cheers. Thanks, Levi. If anybody has any questions, please feel free to type them in the Zoom chat or take yourself off mute and ask.
Okay, so I see one question.
Hmm.
1 second, I'm trying to all the way through. I'm scrolling. So Hive is a command. Does this use the same Hive as Petals? No. So we are like totally distinct from Petals, although amazing project. If you want to do something with them, integrate with them, that would be amazing. But Hive is basically like you could think of it as just like wrapping Docker. So it's like almost like Docker run, but instead of Docker, it's Hive. Because you're running it on our network, and we kind of just like abstract away some of that. That's a great question. So basically, so actually depends which technology. I mean, tokenization of latent computing power or the actual like distributed computing network. So I'll just answer for the tokenization of latent computing power, and if you want, or rather the use of latent computing power, and if you want, you can ask me. I can answer the second question. But basically, um, there have been like hundreds of academic papers published that have been based on volunteer scientific computing. So if you go to Boink, Boinc, and you look up their, look them up, they have like a list of scientific papers that have been published on them. So like searching for asteroids, that's been a big one. Finding prime numbers, which is super valuable. Tons of prime numbers have been found. I'd say in like just, the most recent thing that comes to mind is helping find the structure of the spike protein, the COVID for COVID. That was done very quickly, very early on in the pandemic, and that helped us understand how the virus works and what we could do to stop it. Although I do want to say something really quick, which is I will answer that. That looks really interesting. I'll answer that in 1 second. I will say that one of like the kind of really interesting and critical things here is that what we're looking at are basically new types of markets at the end of the day, right? These markets don't exist. The market for the best use of something that isn't being used, just by definition, it doesn't really exist, right? So we're really entering uncharted territory about what we can do, how we can do it, what kind of value that we can unlock, both financial, societal, etc. And so like that's why it's so exciting, right? It's really just a new way of thinking about, look at all these computers all around the world. Can we do anything valuable, more valuable with them than we're currently doing? So yes, Richard says, okay, so okay, I work on another chain called Commune. We have a similar kind of network that is based on Petals, so I was hoping that it would just work out of the box together. Our system has a similar module system. How hard would it be to interrupt this with a Polkadot style substrate? That is a really great question. And if you did something around that, you would be eligible for a prize for sure. That But to answer your question a bit more in detail, please ask us in the Discord, either on the ETH Global Discord or join our Discord, and you can ask our team there, and they will definitely help you because that is a really, really good question. Yeah, yeah, that's a really good question. Yeah, are there any other questions?
No, that's really good questions. Thanks everybody for asking. Yeah, we can take time for at least one or two more if you have any. If not, as Levy suggested, please feel free to reach out to their partner channel in Discord or their own Discord channel. But yeah, awesome, cool. Well, thanks again, Levy, for the great workshop presentation, and thank you all, everybody else, for attending. We've got a few more workshops later today, so we will see you all here in a bit.
Yeah.
Cheers, thank you.
Thank you so much. Thank you, everyone.